let's learn about integers in Rust. Integers in Rust in a brand new lesson, fresh slate. So integers in Rust are numbers without, and this is important, without decimals, okay? Or numbers that are not fractionalized, all right? Fractionalized like that, okay? So what does that mean? Well, simply put, integers are data types that represent whole numbers, okay? So that's really what integers are in Rust. They're numbers, they're whole numbers. We discussed float data types before, which include decimals. Now we're looking specifically at integers. Within the umbrella of integers, the umbrella, you have signed and unsigned versions that you can specify. So signed integers store, oops, not sortra, store both negative and positive values, whereas unsigned integers may only store negative, not negative, positive values. Meaning that, and let me spell unsigned here. So meaning that any integer that is signed will be able to store both negative and positive, whereas unsigned integers may only store positive values, so from 0 forward, okay? And again, remember, Rust works to enhance safety. Rust is built on this efficient modern idea of safety. And in some cases where you may never want to have a result that is negative, you can ensure that with an unsigned integer. One other very important point. In addition, the size of an integer can be set to arc. Setting an integer to arc derives the size of the integer to the architecture of the machine. All right. So, i.e., if you set it to 64 bits, then you'll have x64 for the machine, right? And this is a basic overview of integers. So, talk is cheap. Let's take a look at some examples. So, if we write a function, our favorite main over here, let's create some integers in this function and print them out and review these fundamental points. So in order to create a variable, what do? We use the let keyword. Let total equal 4, so we'll create a total. Oh, and by the way, if you're not specifying, then the default for the integer is going to be I32. So I32 by default, okay? Let's create another variable. We can call it height. And these are all variables that would in which we would supposedly store integer values, right? So height can be 41. And let's actually make this unsigned. Well, if we want it to be unsigned 32, we could say U32. And now we're specifying this is going to be what? Well, that this should only store a positive value. 41 is within the 32-bit range. Okay, and let's make another variable which could be a calculation, and we can call it a deduction. So let deduction would be I32, and this could be positive or negative, right, because this is signed. So let's get a negative result. So 2 minus 200, right, that would give us a negative 198. Okay, so I want you to pause the video here and print for me the total. And you can even tag the print with a string that says the total is, and then you print the total. So pause the video and see if you remember how to do that. Hopefully you remembered how. If so, great. It means you're following along and you're remembering. If not, have no fear. Let's do it together. So we want a macro, println. The total is, and here we can just put in what? Well, we can put the total. Very, very good, okay? And if we want the height in deduction, let's do that as well. I'm just going to copy this over. You can say the height is, and let's add the deduction. And the deduction is, all right, and let's fix this indent. Wonderful. Close up shop over here, and there you go. Okay, so what do we have? We have a variable integer of 4, which is going to be signed at 32 bits. We have an unsigned 3241 positive. We have a deduction at I32, which should return a negative integer. And then we're printing these out. So let's go ahead and run this code. If I look at the standard output, we're going to see that the total is 4, the height is 41, and the deduction is negative 198. And perfect. And this would be perfect. This would be perfect. Can we change 41 on the unsigned 32-bit to negative 41? Is this possible? Well, if I try running the code again, we're going to see we get an error. We get the error in the standard error box above. The error message is EO600, which is that it cannot apply the minus operator to type U32, right? And we know that it can't do this. We know that it can't do this. This is what we wanted because we assigned it U32. So all is well in the Rust integer world. The rules are being abided. Okay, so this is a good look at the fundamentals in integers. Let's stop right here, and in the next video, get deeper. Let's get a little bit more deeper and complex. Okay, I'll see you there. Bye.